All right, so we're going to look at buffers, which are a very important part of acid-base chemistry. So first thing is, what is a buffer? We have this definition in a lot of different ways, like, outside of chemistry. But for chemistry, it's basically a solution that resists changes in pH. So you can add acid, you can add base, and its pH will still increase or decrease, but not by as much. So if you took pure water and added just a tiny bit of acid to it, its pH would drop really quickly. But if it were buffered, it would not. And one really famous example of buffer, or at least a really important example, is blood. So your blood is relatively neutral, slightly basic, but if you get all of a sudden an influx of acid or base to it, the chemical system in the blood will prevent the pH from changing wildly, which is really important. So that's one type of buffer, and there's many, but I just want to show like a real life example of it. So to be a buffer, you have a solution that has to have two things in it. One thing is a weak acid, and hopefully we know the weak acids are any except those strong ones we went through last time, and it's conjugate base. So that's one type of buffer, or you can have a weak base and it's conjugate acid. These are the same thing really, just two different ways of sort of saying it. But that's what we need in a buffer. So let's look at one buffer. So here is a beaker, and I've added a mole of hydrofluoric acid, which is a weak acid, and I've added a mole of sodium fluoride, which is the conjugate base. The conjugate base of HF is F minus, and adding NaF effectively adds F minus. The Na just kind of goes into the water, doesn't really do anything. So this is a buffer solution. Now let's see what happens to this buffer solution if you add some acid to it. So if I put a bunch of H plus in the solution, this is an acid, and what happens is we look at the equilibrium of this buffer solution. HF becomes H plus and F minus. This is at equilibrium. So adding H plus, we know from Le Chatelier's principle, if this increases, it's going to shift to the left. It's going to want to make more HF. And if it does that, it's going to consume some of our F minus. So that's fine. So we have plenty of F minus in here. It's going to react with the H plus, and it's going to make HF. And as a result, let's say, this is just numerically, I added 3 H pluses. A couple of them will be sort of neutralized. So there'll still be more H plus than when I originally had the solution before I put these 3 in, but not by as much. So this is buffered against the acid. So it'll still drop a tiny bit, but not by as much if this were just regular water. So that's the buffer against acid. Now let's say I add OH minus, which is a base. The OH minus is going to immediately react to the H plus, neutralize the H plus currently in there. It'll turn it into water. So that's what happens when you have OH minus and H plus, it makes water. So you've lost some H plus. So again, from Le Chatelier's principle, if H plus decreases, the principle says we want to replace it. So the reaction is going to shift to the right. So some HF that was already in solution will then break apart and replace a lot of that H plus that was lost originally. Not all of it, but a good amount of it. So again, it's buffered. We added the base, its pH will go up, but not by as much as if this buffer was not present. So it's buffered in both directions because it has a weak acid, which can buffer and prevent the base from having a major impact, and it's got a weak base, which can prevent the acid from having a major impact. They both can coexist. One question is, why does this not work with a strong acid-base system? So here's HCl, which we know is a strong acid. Its conjugate base is Cl minus. So if I made a buffer out of HCl, which remember, they're all going to dissociate right away, and NaCl, so I have a whole bunch of extra Cl minuses in here, this is a buffer of a strong acid and base. So what happens? Well, if I add some H plus to it, the H plus is going to go in, and usually this is where the base would take charge and sort of neutralize that. But because Cl minus is the conjugate base of this HCl, Cl minus is a really weak base. This reaction doesn't really go in the reverse direction. So Cl minus can't neutralize the H plus because even if it could combine and make HCl, it's going to immediately break back down. So this is not buffered against acid. Any more acid added will make it more acidic. If I try to add OH minus, the OH minus will neutralize the H pluses, but then I don't have any reserves. Before I had HF, which could then break apart to replace those H pluses here, what I see is what I get. There are this many H pluses in there. I've neutralized them. I have no way of getting more. So it's not buffered against OH minus really either. So again, strong acid, conjugate base is not going to work for a buffer. It has to be a weak acid and its conjugate base, or again, a weak base and its conjugate acid. So last thing we'll do in this video is just pause this, try these out, figure out which ones are weak acids, which ones can work as buffers. So take a minute to do that. Okay, so hopefully you've unpaused it now, so let's take a look. So HCN is a weak acid. Its conjugate base would be Cn minus, and NaCN, anytime we're looking at these salts, you can pretty much ignore alkali metals. They're just gonna drift off into the water and not do anything. So Na plus we ignore, Cn minus, this is a buffer system, HCN and Cn minus. HBr, you might remember, is one of our strong acids. So Br minus is its conjugate, but this is not a system that'll work because it's a strong acid. NH3 you might recognize as ammonia, that's a weak base, so its conjugate acid would be NH4 plus. If this dissolves in water, it will make NH4 plus and Cl minus, so this is a weak base conjugate acid system. This is in fact a buffer. H2SO4 is a strong acid. Its conjugate base then, HSO4 minus, the system will not work. Again, we can ignore the Li. Now KHSO4, when this dissolves, it's going to make HSO4 minus. That actually is not a strong acid. H2SO4 is, but the second one is not. So HSO4 minus and SO4 2 minus, that's the conjugate base. This system will be a buffer. So again, our buffers here are going to be A, C, and E. So there's some practice in the workbook to try as well. Hopefully this makes sense. We're not going to get into the mathematical calculations with buffers. This is something you would do potentially in AP chemistry, but not here. We're not going to go that deep. So for now, I just want to know the conceptual idea, what a buffer is, and what do you need to make it. So until next time, I am Derek Genova. Have a delightful day.